Welcome back, guys. This is acids, bases, or neutralization reaction. So it should be very short because this is one of the easiest ones. So let's get started. Okay, so again, write everything down, bring it to class, summarize it. There will be a couple of practice problems at the end that I want you to try. Okay, so in a neutralization reaction, it's a reaction between an acid and a base. The products, and this is the key here, okay? The products will always be a salt or an ionic compound and a water. Okay, I can't draw for some reason tonight, but that's okay. Let's see if it changed my pen color. Okay, so that right there. The other thing is we got to have an acid and a base. I don't know why my pen is not working right tonight, but we have an acid and a base. Okay, so what does that look like? So we have the acid and we have a base. We produce a salt and a water. And this is a salt, not salt itself. Okay, so if I take hydrochloric acid and sodium hydroxide, I'm going to get sodium chloride and water. Okay. Here's the key. An acid will start with an H. Okay, and it should, if it's words, it'll have the word acid in it. If it's a base, it will have an OH at the end, which is a hydroxide. So we'll start with a hydrogen. Okay, hydrogen. And I can't get the G-E-N. Okay, that's supposed to be an N, not an M. Okay, and then we have a hydroxide. Which is a polyatomic ion. Okay, what is going to happen is these are going to be also going to be a double replacement reaction. Okay, and what's going to happen is the hydrogen is going to swap places with the sodium, and the sodium's going to come over here and join up over here. Okay, we get sodium chloride and water. Okay, we'll learn this later. We just kind of know this, that the pH is not always 7, but 7 is a neutral water. Okay, that's for later on when we actually get into acids and bases. Right? So in a neutralization reaction, you're looking for a hydrogen. Well, here's a hydrogen right here. Here's the OH right here. That is a hydroxide. So this is the acid, and this is the base. Okay, acid-base reaction. The hydrogen is going to switch places with the potassium, and the potassium is going to come on over here and join the nitrate, and we end up with a water, and here is your salt. I cannot write tonight. I apologize, guys. Okay, so we have an ionic compound. Okay, it's an ionic compound right here. All right, so let's move on. Okay, so here's a word equation. Okay, so they'll give you hydrochloric acid. Well, I'm going to give you this one on the. If we give it to you, I'll give it on a test other than it's HCl. I either say it's hydrochloric acid and then I'll put the formula, or I'll give you the formula to begin with. Reacts with, okay, so that's my plus sign, sodium hydroxide, NaOH. They're both plus ones, okay, and then they're going to produce, there's my arrow, sodium chloride, NaCl, and a water, H2O. Okay, so when you rewrite this formula, you just get HCl. Cannot draw tonight. I don't know what's going on with this pen. NaOH. And it goes into NaCl plus water, H2O. I don't know why I ran out of room, but H2O. Okay, so there's all your pieces. All right, so you have your salt, which is NaCl, and your water, which is H2O. All right, so here's your predicting products. This is what I want you to do. If you go back up here, you notice that the H switched places with the NaCl. The NaCl came over here and switched places with the with the H. Okay, so on yours, I want you to bring these two to class. Oh no, I take that back. These are ones we're going to predict. So to predict the products, well, here's my hydroxide, here's my hydrogen. Hydrogen is going to switch places with lithium. Lithium is going to come over here. Okay, so we have LiSO4. Now we have to do one thing here. Lithium has a +1 charge, and I can't put it up here. Lithium has a +1 charge, and sulfate has a -2 charge. So we have to put this 2 right here. Okay, plus, and here's my salt, and then we have water, H2O. Okay, so we'll always have a water, and we just have to kind of come up with the formula for the salt. Okay, so here we have barium hydroxide. Okay, hydroxide is the base, carbonic acid, which is H2CO3. The hydrogen is going to switch places with the barium. So even if I give you words, you need to know that barium is Ba. I cannot draw. Ba, and it's going to switch places with the hydrogen. So CO3, if you look on your polyatomic iron chart, has a -2. Barium has a +2, so it's going to be BaCO3 plus H2O. Okay, it's getting kind of long, and I didn't mean to. It's because I'm having trouble with my pen. But here's the one that you need to bring to class. You're going to translate it, and then you're going to try to predict the products. Okay, I'll see you in class.